Okay, guys, good evening. We're going to start our meeting now. Please remember the rules. Keep your phones, the video off for privacy reasons. Please remember that you need to wear headphones because right now I'm hearing an echo.
Sir, I'm not at my house, sir, and I don't have my earphone, sir.
Let's try this again. That's too much. You can't use that. You have to turn it down or you have to watch only. That echo is going to be too much.
Sir, it's not my phone echoing, sir.
I know, mine.
Sandra, you have on headphones?
Yes, sir, I found one, sir.
No, background is noisy.
Trishan.
No, it's not me.
Somebody has a TV playing in the background or something like that.
Not me.
Sandra, the background is yours. Okay, let's start. Are we ready?
Yes, sir.
Okay, so here we have a problem. 1,864, and we're going to add to that 1,429. Some points to remember. Add plus add is equal to. We need to go column by column and pay attention that each digit is under another digit. Okay. So
Yes,
9 and 4 would give me what?
9 and 4. 9 and 4 will give you 13, sir.
Okay, let Trish answer this one, please. So I'm going to write 3 and carry 1.
3, that one.
So 6 and 1 would be what?
7,
And 7 and 2 would make?
9.
Sandro, I can hear you whispering, and everybody will be hearing you whispering as well. So I'm asking you to get your background quiet, or I'm going to have to ask you to leave and watch, okay? All right, so let's go on, Trish. So 8 and 4 would make what? Okay, so I'm going to write, so if it's 12, I'm going to write 2 and I'm going to carry 1. What do I have in this column?
3.
Okay, so 1,864 plus 1,429 will give me a total of
3,293.
points to remember. Add plus add equals sum. Let's work column by column and remember to place digit under digit. Sandra, this one is yours. Read for me.
25.56 plus 2.88 plus 73.66.
Points to remember. Add and add will equal to sum column by column, digit under digit, and decimal point under decimal point. So let's go, Sandro. 8
Yes,
and 6 will give me
8 and 8, 6 and 6 is 12, and 12 plus there is 20.
So write 0 and carry.
2.
Okay, add for me 2 and 5. Or
5 plus 2, 7 plus 6. 7 plus 8, sir, is 7 plus 8. What again? 15 plus 6. 15 plus 6. 21, sir.
okay. 6 and 8, 14, 14 and 5, 19, 19 and 2, 21. We're going to write 1 and carry 2.
Carry
Decimal point under decimal point.
point.
2 and 5.
7.
Oh, 2 and 5, sir, is 7, sir. And
Okay.
7 plus 5, sir, is 12.
Okay, so if it's 12, we're going to write 2 and carry 1.
And 10, sir.
My answer will be
102.10.
okay, not 0.10, 0.10.
0.
Okay. Let's go back to Trish. Trish,
Yes, sir.
what is the highest common factor of 100 and 150? Points to remember. Prime factorization. Start with the smallest prime and remember the divisibility rules. So 100.
Sir, I would write 50.
I'm not hearing you clearly.
Sir, 50.
Let's start with the smallest prime. What's the smallest prime?
2.
Okay, so 2 into 100 goes
25 times, sir.
2 into 100.
Sir, I'm not sure.
100, we're going to divide by 2. 2 into 10, 5, 5 twos, 10. Subtract, get 0, bring down 0. 2 into 0 will give us 0. So 2 into 100 goes how many times?
50 times.
Okay, so 50. We're going to use 2 again because this is an even number based on our divisibility rules. So 2 into 50 now would go how many times? If I have $50 and I break it into 2, what do I get?
Sir, like 25, sir.
Good. Divisibility rules. I can't use.
Sir, I'm not hearing you.
Somebody just came in with their microphone, their background, their camera showing. You need to turn the camera off and turn your microphone, your volume down. Use a headphone if possible. So let's go. So can't use 2 because this is not even. Can't use 3. I can use 5. 5 into 25.
5 times.
Okay. And 5 into 5.
1.
1.
Talk to me, Renee. Talk to me.
Those interruptions are not welcomed, please.
Right properly walk.
Let's continue. So we have 100. The prime factors being 2 by 2 by 5 by 5. All right. Have to turn down the microphone so some of those people, the background's too noisy. So let's continue. So we'll go now to 150. This is an even number, so we can go with 2. 2 can go into 150 75 times.
But sir, we can't use 3 and there. 75 is not an even number.
Okay, so we can use 3. How many times can 3 go into 75?
7.
3 into 7 would go 2 times. 3 twos would give you 6. Subtract. We have 1 left. Bring down the 5, and 3 into 15 goes 5 times. Answer.
25.
Okay, so 25. We can't use 3. We could use 5. 5 into 25, as you did here, would be what?
5.
5. Good. And 5 into 5, 1. So 150
Will be 2
as a sum of its primes would be 2 by 2,
3
no, by 3 by 5 by 5.
5.
Let's look for the things that are common. 2 is common.
And 5 is common.
5 and 5. So 2 by 5 by 5. So 2 5s would be 10.
10.
And 10 times 5. 10 times 5 would give us what? 50. So the highest common factor of 100 and 100 and 150 would be 50. So if we're reducing 100 over 150, we could use 50, and we could say 50 into 100 goes 2 times, and 50 into 150 goes 3 times. This would be reduced as 2/3. Points to remember: prime factorization, start with the smallest prime factor, and remember our divisibility rules. We're moving on. Let's look at this question that talks about sequence. For sequencing, we need to look for the pattern, look for the rule that appears between the numbers so that we can predict. So this is 0.05, 0.10, 0.15, and 0.20. What would come next? This looks like 5, then 10, then 15, then 20. So we can predict that we have 0.25. So they seem to be adding, going up by 5 each time. Let's look at this one. 3/8 of 176. Points to remember: we need to know what of means in mathematics. In mathematics, of means to multiply. So this would be the same as 3/8 multiplied by 176. Let's reduce where possible. So we're going to say, how many times can 8 go into 176? We could set that out here. So 176, and we see how many times 8 can go into it. So 8 could go into 17 2 times. 2 times 8 would give us 16. We subtract and we get 1. Bring down, we have 6, and 2 8s would give us 16. Again, we subtract, we get 0. Please remember that every dog must swim back. Estimate, divide, multiply, subtract, and bring down. So this would go 2 times as well, because 2 8 would give us the 16, so we have 22. We can check our answer by multiplying the quotient by the divisor to see if we get the dividend. So 22 multiplied by 8, 8 2 is 16, carry 1. 8 to 16 and 1, 17. We end up with 176. So 8 into itself one time, and 8 into 176 would go 22 times. Now we're going to say numerator by numerator. So it would be 3 times the 22 over denominator by denominator, 1 by the 1. So we end up with 22 times 3 would give us 66 over 1. 66 over 1 is the same as 66. As a decimal, we have 15 over 100. Points to remember, a fraction is another way of expressing a division problem. The numerator is the dividend and the denominator is the divisor. We're seeing how many times we can get 100 out of the 15, or get it divided by 100. So simple, we're dividing by a what? Power of 10. We have 2 zeros there. So this tells us or indicates the number of places that we're going to be moving our decimal point. So our decimal point is here in a whole number. It's not visible. It's not stated. So let's go. We know it's there. So we're going to move how many places? 2 places. So we go 1 place, 2 place. So now we would end up with something that looks like this, 0.15. Again, points to remember, a fraction is another way of expressing a division problem. The numerator is the dividend and the denominator is the divisor. So we can set it out like this. We could say 100, the what? Denominator, and 15 would be the what? 15, the numerator. This becomes the dividend. So 100 into 15, that couldn't work. We'd have to add 0 at a decimal point, add 0 to continue. So 100 could go into 150 one whole time. 1 times 100 and 1 times 100 would give us 100. Subtract, we would get 50. We would need to add a 0 to continue. We're behind the decimal point. And now 100 into 500 would go 5 times. 5 times the 100 would give us what? 500. We're going to subtract and we end up with 0. So either way, this proves here, our division problem here proves that 15 divided by 100 is equal to 0.5. Now, instead of working it out this longer way, we could simply move our what? Decimal point. When you get to high school, you will not be moving decimal points. This is just for now. So it would be 1, 2 places because we're dividing by 100, which has 2 zeros there. We have a number here, 61.78, and they want to know which digit is in the 10th place. So let's work this out. Before we go, points to remember, each digit in a number has a face value, a place value, and a true value. So let's look. We have the decimal point, we have the ones place here, and then we have the tens place here. To the right, the first digit would be in the 10th place, 1 out of 10, and the second place to the right of the decimal point, this would be the 100th place. So we have 6 tens, 1 ones or 1 unit. We have 7 tenths and 8 hundredths. So let's look for the 10th place. So it says now, what digit is there? 7. So this would represent 7 tenths or 0.7. Here we have another set problem. It says now, which element is in the intersection of set A and set B? So we have set A, we have set B, we have in set A 7, 3, 5, and 2, or 2, 3, 5, and 7. In set B, we would have 2, 4, 6, and 8. outside of that, we have 9. So what is in the intersection? The intersection is where both of them overlap. And in that section, we have 2. So our answer for this section would be 2. The elements of set A are all dash numbers. Are they all prime? Set A. Are they all odd? Well, they are not all odd because 2 is an even number. So we can rule this one out. Even, they are not all even. 2 is the only even number there. So they are not all even. Composite? No. Composite numbers have more than 2 factors. So they are not composite because 2 has only 2 factors, 1 and itself. 3 has only 2 factors, 1 and itself. 5 has only 2 factors, 1 and itself, meaning 1 and 5. And 7 has only 2 factors, 1 and 7, or 1 and itself. So these numbers are not composite. All of these numbers are prime. So the answer for the first section would be 2. 2 is at the intersection of set A and set B. And all the numbers of set A are prime. What's this 9 again? This 9 is a part of the universe, but is not a part of set A or set B. Here we have an addition problem, decimal addition problem. Remember what we said earlier, column by column, digit under digit, decimal point under decimal point. So let's go. What is 0.08 plus 0.328 plus 6.2? So 0.08 plus 0.328 plus 6.2. We're going to fill in our placeholders. We need 1 and 2 here. We need 1 here. Let's add. So 0 and 8. This would give us 8. 8 and 2, 10. We're going to write 0 and we're going to carry 1. 3 and 2, 5 and 1, 6. Decimal point under decimal point, we have 6. So 6.608. If we were to look at this, this would be our ones column. We have our 1/10ths. We have our hundredths. We have our thousands. So we have 6 units, 6/10ths, no hundredths, and 8 thousands. Let's look at this question now. It says, if something in a box plus 3 more would be equal to 12, what does the box represent? So let us remember these things. An expression versus an equation. An algebraic expression does not have an equal sign, while an equation will have an equal sign. We need to remember that they need to be balanced in order to be true. And the property of equalities suggests that whatever is done on the left-hand side must be done on the right-hand side as well. So we have our box plus 3 would be equal to 12. So if this side, which is the right-hand side, let's say right-hand side, is equal to 12, what is happening over here should also be equal to 12. So whatever is in the box plus 3 should be equal to 12. One way of looking at this is to say we need to get the box by itself. So we need to subtract 3 from this side. So if we have box plus 3, then we need to take away 3 from this side. So, and we have 12 there. And whatever we did on this side, what did we do? We were taking away 3 here from that side. So we are going to also need to take away 3 from the other side. So the left-hand side, we took 3 here. So on the right-hand side, so that we are balancing what we're doing, and what we do on one side based on the property, we do on the other side, we're going to take away 3. So 3 will cancel 3. So all I'll be left with is the box on the left-hand side. And On the right hand side, 12, and we take out 3, we should get 9. Okay, so if we have 9 here, let's substitute now another term we need to be familiar with. We're going to take this 9 and we're going to do what? Place it wherever we had the box before. So before we had box plus 3 should be equal to 12. Let's see if that is true. So we have 9 plus the 3 should be equal to 12. 9 and 3, 12 is equal to 12. So this is true. Once we work our way down and we get it where we have the same value on both sides, then we know that it's balanced and that we're good. Points to remember again, what's an equation versus an expression? We need to remember the term balanced and what that means. We need to look at properties of equality, meaning what we do on the left-hand side of the equation, we also need to do the right-hand side. So for example, here we were taking away 3. So we need to take away 3 on the other side of the equal sign as well for it to be balanced. Subtraction of decimals. Let's look at this. We have 0.42. So 0.42. And we're going to take from that 0.163. Let's fill in our placeholders as needed. So 3 from 0, that can't work. We have 2 here. I'll take 1. This 1 will come now and make a set of 10. So 3 from 10 will leave me with 7. 6 from 1 can't work. Take 1 from the 4, leaving me with 3. That 1 set of 10 and the 1 will make 11. So 6 from 11. This will be 5 because 6 and 5 will make 11. 1 from 3 will leave me with 2, decimal point on the decimal point, and I put a 0 here to help us to identify the decimal point easily. So 0.42 minus 0.163 will leave me with 0.257. 2.84 in expanded form. What is that? So we have 2 in our ones section. We have in our tenths 8. We have in our hundredths 1 part out of 100. We have 4. So let's start with the bottom. We have 4 whole being here. So we know this is wrong because in the number we only have 2 whole. So that's wrong. We have 2 whole here. That's good. We have 8 hundredths. No, but this is tenths. So this part is wrong. And if one part of it answer is wrong, the whole option is wrong. So we have 2 plus 8 hundredths again, wrong place. So that's wrong. So we should have 2 whole, yes. 8 tenths, yes. And 4 hundredths, yes. So option A is correct. So here we have a decimal and we have changed it into what? The fractional sections so that we can see it to see how it would be in expanded form using the whole number and what? Fractions. So there is a relationship between whole numbers and what? Decimal fractions. So let's look at this now. It says, what is the product of 371 and 6? So 371, and we're going to multiply this by 6. If we're multiplying, because we're using the word what? Product. 6 times 1 would be 6. 6 sevens would be 42. So we're going to write 2 and carry 4. 6 threes, 18. 18 and 4 would give us 18 and 4?
What?
22. Okay, so let's go 1, 2, 3. Let's put our little comma here. So our answer would be 2,226. So the product, what is the product of 371 and 6? The product is 2,000.
226.
Okay, good. Now, if we have 364, if we wanted to identify the 6, which of the following represents the true value of the 6? Is it 6 times 1, 6 times 10, 6 times 100, or 6 times 1,000?
6 times 10.
Okay, 6 times 1 would be what?
6.
Good. And 6 times 6 times 10 would be
60.
very good. And 6 times 100 would give us
600.
excellent. And 6 times 1,000 would give us
6,000.
6,000. Okay. But this says 364. In expanded form, 364 would be equal to 300 plus 60 plus 4. So here, and this is our hundreds or tens and or ones. So here we have 4 ones. The 60 would be 6 tens, and the 300 would be for the hundreds. So the 6 represents 60, or 6 by 10. 6 being multiplied by 10. Well, that's it for tonight. Please remember to review as best as you can. We added some points to remember as we were going along. So take your time when you watch the video over to pay attention to the points to note. Please take care, and I'll see you in the next episode.
Yes, sir.